Okay, here's a new series of demos. We're going to throw in a bunch of other stuff here in this series of different videos. So to start, we're going to look at using some new Nysthi modules here. This one in particular, the complex simpler for recording some audio and then playing it back in weird, cool ways. This whole kind of weird patch is going to use this module called Caudal by Volt, which is generating 12 different channels of random noise, essentially. And we can kind of see some of the this kind of darker blue line here. And this is kind of running the whole show. So instead of a sequencer, we've got this, and then running it through a comparator by Modular. We set a threshold, and then whenever those values from Caudal are above or below this threshold, we have these different gate triggers over and under. So we can use that to control a whole lot of different things. We're also going to be looking at some percussion modules, like hi-hat from Hora, this ride and kick from Autodaf, using a regular kind of kick, so instead of a clock or a sequencer, just using a regular LFO with a square wave to get a regular trigger, so much like a clock. And then also focusing on this beast here, this Mixmaster and Auxpander modules. So these are actually two different things here. When you put them together, they work together. So we're going to focus a little bit on the mixing console here, and then also learn what aux channels are, what that means, what a send and a return thing means. So what we have going here, we've got these 4 other effects modules. So our reverb, we've got our delay, and 2 more from Volt that are really great. These Flame is a distortion that really kind of creates a gritty, really distorted sound, and then this chorus is really beautiful, just adding a little kind of a stereo effect, kind of a shimmering chorus effect. And by doing it as aux sends, each of our voices that we're inputting to the mixing board here, we then are able to send it in variable quantities, like send a little bit to plateau, send a little bit to the chronoblob, right? We can kind of share, all of our voices can share these 4 effects in differing amounts by doing it as this aux send and return situation. So we will go through all that. Let's before we even listen to the whole thing, let's just go ahead and dive into the simpler. I'm gonna show this here, and right now, actually, let's just isolate this a little bit so we can see what's happening. Let's shove these guys over here. And okay, and what I'll do is I'll just turn off all of the effect sends, so it's not going to sound quite as cool. So maybe just to show, maybe before we get into the triggering here, let's just kind of look at what the simpler does. So I'm going to turn off this little trigger situation. So what we did already, I recorded this little vocal sample. And in fact, maybe let's just, we'll get rid of that for a second, and let's stop. I have this hooked up to this right here. So actually what I need to do, because we're going through Black Hole to get into OBS here, but in order to use this, I need to get another audio and connect that to my microphone. From there, let's do it from here, and let's just make sure. So hit record, check 1 2 3. Okay, beautiful. That seemed like it works. So let's just play something. And that's my wonderful sound here. So then, so technically we don't really need this anymore. We can just go out from right here. So let's go low pass. That's still hooked up, and let's just hear it. And I tend to add a filter over pretty much every voice because, you know, every voice you want to have that power to kind of shape the sound a little bit. In the tangents here we've used a lot. So a very common, very great filter. Just adding a little low pass here. The great thing about Simpler, right? Very easily we can control speed. Right now it's going at 0.5. So there's some cool things we could do with that. I'm just going to leave it at 0.5. The relationship between pitch and speed is important to know also. So if I have speed at 0.5, that means that the audio is essentially 1 octave lower than it used to be. Because if you think about, let's say like a 440, let's just bring this down a little bit. A middle A note, let's say, is 440 hertz. The A 1 octave below that is 220 hertz. So there's always a kind of half relationship. The A note 1 octave above that would be 880. So you've got a doubling or a halving relationship between octaves. This is talking about frequency, not about voltage, right? So the voltage situation isn't doubled or halved. It's just 1 volt per octave. So that's a difference to keep in mind. But when we do speed 0.5, that's essentially having the frequencies in my voice, and it's creating a sound that's essentially 1 octave below what it was before. So good to know. And just other tricks here, right? Other like FM, kind of some weird little tricks here. Let me try. You know, we can add CV to all this stuff. So this is coming from Caudal here. So I've got a little random. If we can see. So what does this look like right here? Cool. So that's really changing the frequency a lot right there. Also, it's hooked up to the cutoff point here, so it's modulating the cutoff. So this is, you know, pretty cool, pretty simple. We can do all kinds of different things with it. I'll just turn that off for now. You know, I could play with the speeds dynamically. By default, the cycle is turned on, so it's just going to loop over and over and over. If I want to do something else like, let me turn that off. Let's stop that. You know, we can choose start and end points here. So just drag this. And if I do trigger, and actually let me zoom. That's not what I want to do. That's good enough. Maybe a little bit more, a little bit shorter. So now that cycle is off, it plays what's called a one shot. So it's triggered, it plays through that one time, and then it stops. So by doing, by controlling, record something, control the start and end points here, turn off cycle, and then you get a trigger right here. So that enables you to do something that's a little more, I wouldn't say that's quite percussive quite yet, but something more triggered, less ambient. So what I'm doing with Comparator here from Count Modular, we can see I've got this input right here coming in, and let's see that on the scope also. So Caudal, similar to the random module by VCV that we looked at before, by default is going from +5 to -5 volts. And maybe I'm complicating this here also because I have another little tiny LFO by Bug Audio, which is coming out here and modulating the speed of Caudal, which is creating these kind of different patterns of speed coming up. So let's just get rid of that for a moment, and we can kind of just see nice sort of simple kind of almost like a sparse noise. So what this comparator is doing, I've got threshold of 0. So the 0 line is this middle line right here, right? So if we go, if this value goes above 0 volts, because that's my threshold, then the over gives me a gate. If it's under that, then the under thing gets a gate, right? So pretty cool. So I could use that to do something like this here. So every time it goes over, and actually for this one, it's triggering it when it releases also. So you get it kind of like a double. You know, if I wanted to change this into a more proper trigger, you know, what I might do is go back to our gate mod that we used before. So I could, you know, bring in this this gate actually and make it super short. But that's like whatever. That's all kind of just arbitrary. You can shape that however you want. So that's pretty cool. So what I was doing before actually was kind of opening this up. I had cycle on, you know, bringing the end all the way there, and then allowing this comparator to do this trigger stop slash continue. So when we do that, so every time this kind of gate's on or off, it starts and stops it. Let's wait for it. Right, okay. Or at least it should be. Let's try it again. Okay, there we go. Now it starts again. There we go. Okay. I just had to trigger these manually at first to get them working properly. So now I've got this audio file that is according to this random values. It is sort of randomly starting and stopping, and then going through my filter. So it's just kind of adding a little, you know, ambient, little windy sound there. I guess a little bit more about Caudal. This is, you know, just a really great. We looked at the random module, and you know, thinking about, you know, thinking back to Touch Designer, let's say, like a noise chop as a way to modulate a parameter of something else. You know, thinking about modular here, it's nice to kind of modulate everything a little bit, so everything kind of is moving around. It kind of adds some vitality to everything. But then if we were using a you know, gazillion random modules here, it just kind of gets kind of cluttered. There's like, you know, these take up space and they're kind of going all over the place. Even though they have like 4 different output, it's still based on the same random seed. So the cool thing about Caudal, so again, I recommend kind of right-clicking, go to Info, and going to User Manual for a lot of these. So we can see list. Here's the volts list. Caudal's right here. So here, little description. So it's a chaotic source based on the model of a multi-segment pendulum. So this is pretty cool. So it's a detailed simulation of the pendulum system based on the angular velocities and positions of the segments. So the developer of Volt is really great. So he's looking at for the filters, he's looking at like hardware voltage and like studying those voltage values. And for this, he's looking at a double pendulum, which is this model right here. So you can kind of see. So it's actually a double pendulum with 1, 2, 3, 4 segments. So the outputs of Caudal, so this is the 4 segments A, B, C, D, and the X position of those 4 segments, the Y position, and the angle value of the 4 segments. So by kind of seeing this simulation, that's essentially how the random values are generated. So it's just maybe maybe it doesn't really matter, but just kind of interesting to see how those values, like what it actually comes from. That there's a really detailed simulated model that's generating that randomness. If you haven't seen real videos of a double pendulum, I recommend it. Check it out. It's a really interesting source of chaotic mechanic motion. And we've got different settings, so you can play around with these. The Pendulum Planets fish tank, there's slightly different models. They have different shapes. Speed makes it much faster. Slow, fast. There we go. Energy just changes its behavior also. And so what I was doing here with the other little LFO by Bog Audio, we can see, so that's coming out. I have it set to step mode and pretty slow, so roughly like 4 times a second. So in step mode, it's essentially giving random outputs according to this frequency, but I'm using that value into the speed input, opening up the attenuator, or attenuator, I should say, a little bit, and then that's kind of changes the speed of this. So let's start a little bit slow, and then so we can see how the randomness is. Like right now, it's pretty slow, and as this noise gets higher, it's going to change the behavior of our Caudal. So let's open that up a little bit more. Let's do Pendulum. I kind of like Pendulum. It's a little bit more like smoother motion. Okay, there we go. So for instance, you can see right here. So when the LFO got faster, the Caudal also kind of suddenly has very fast changes. So this is another way. If this is functioning like our master, it's almost like a master random chaos clock instead of like the regular clocked module that we used before. This is going to add some variation of like fast and slow. Okay, cool. Let's have a listen to the effects maybe in the next video. So that's good for the first one.